Hello everyone, thank you for joining us. I'm Patricia Simon. I'll be your moderator for today's webcast, Leveraging IoT to Solve Energy Market Challenges and Enable Transformation. Today's webcast is presented by our partner Orhan Dengiz, CTO of DvM Technology, and Scott McCarley, Senior Director of Solution Management at ThingWorx. So we'd like to thank Orhan and Scott for joining us today. If you would like to ask any question during the webcast, please do so via the question section of your GoToWebinar pane, and we'll address and answer them at the end of the webcast. We'll also be sending out the webcast replay according to when it will be available. Now I would like to hand over to our first presenter, Scott.
Thank you, Patricia. Hi, everyone. Thank you for taking the time to attend the webcast today. I'll just take about 10 minutes to introduce ThingWorx, some of the challenges we see in the market and the opportunities for participants in the energy market by leveraging IoT, and then I'll hand it over to Orhan. So with that, let me just introduce ThingWorx. So ThingWorx is a business unit of PTC. PTC itself is a $1.3 billion software company that's been around for about 30 years. Within the ThingWorx business unit, we have over 800 employees dedicated to IoT. There are thousands of ThingWorx compatible partners and solutions in the market today. It has established itself as the leading platform, the most proven platform out in usage in the market. So ThingWorx itself is an IoT platform, and it enables innovators to rapidly build and deploy game-changing IoT applications, solutions, and to deliver new experiences to end users that can meet today's energy needs. So ThingWorx platform delivers, from a capability perspective, it delivers software to connect sensors and device information to the cloud. It delivers a groundbreaking, purpose-built IoT rapid application development environment that enables the creation of new IoT apps using visual modeling and drag-and-drop UI construction. There's also analytics software to uncover valuable insights within big data sets without usage of data scientists. Additionally, it has software that enables new users to experience IoT in exciting new ways, including augmented reality. So the energy market today is undergoing major transformation. Some of the forces that we see acting on it are, in addition to growing demand, the world is moving away from the use of centrally generated nuclear and fossil fuel electricity. It's moving towards the use or the greater use of distributed renewable energy resources such as solar, hydro, and wind. New energy storage devices, for example, batteries for buildings and cars, are also impacting the energy market. And energy consumers, businesses, governments, and even municipalities are more focused than ever on efficiency and sustainability goals. Finally, in some markets across the world, the market has become deregulated, forcing some energy businesses to divest themselves of particular areas of their operations. This has posed a number of challenges for businesses. So the first is, with a growing number of injection points from new distributed energy production, the power network is facing major stability challenges. So production must equal consumption, and energy suppliers must be able to control the amount of energy produced. So these new variable sources of energy production pose new stability challenges. With all of the new players in the market and all the new people requesting information, being it end consumers, municipalities, new suppliers, everyone needs more information regarding consumption and production information regarding energy. Cost is always a concern to all participants, whether a consumer or as an operator of a network, the cost of service of the new equipment within it, as well as the cost of energy consumption. So cost is always a challenge. And as people have had to divest themselves of operations in their business, they're looking for new additional revenue streams and new opportunities to increase their revenue. So IoT presents an opportunity to meet some of these challenges. IoT enables people to connect the things of this world in the physical with the digital information you might have in your systems along with people. So by combining this, we're able to solve many of the challenges we've just discussed. And in particular, I'd like to just talk through a few use cases that we see in the market. So centralized generation. Here we can leverage IoT to bring together energy production information across multiple facilities, whether it's coal, gas, or nuclear, into one solution so that we can better predict energy production, have greater visibility. We can also do things like better monitor the energy quality. Within grid operations, now we can look across distributed production along with fixed generation to make sure that we're meeting the production requirements and controlling for the variable production from renewable instances or distributed power generation. We can also do things like ensure that we are protecting our equipment from theft and additionally remotely service it. From an actual manufacturer perspective in distributed energy and for the utilities, you can now remotely service these pieces of equipment, monitor them, and better predict their energy production based upon all sorts of information. On the meter side, IoT can be leveraged in smart meters to introduce new consumer programs, such as demand-side management, but it can also be used as an endpoint to better detect outages in the network. So there's a lot of new potential for IoT leveraged across the entire grid. Conventionally, when people look to build IoT solutions to build out some of these, solutions, they looked at it as a very tactical project. So they're delivering an IoT point solution. Some of the challenges of that, though, are you create all of these information silos, and when you build an application, it's difficult to maintain and evolve because you have a fixed set of resources associated with it that have built it from the ground up. Ultimately, that's a high cost with different solutions having different and unproven security and scalability issues. And frankly, overall, it presents a barrier to innovation. By taking a more strategic approach, by leveraging an IoT platform, you can execute on an individual project as one component of a holistic system with the ultimate goal of driving a better outcome across the entire system, across all of the solutions. By doing so, you'd also enable the sharing of development resources, enable better data sharing across different solutions, deliver a single model for scalability and security, create resources that can maintain and evolve applications across all of the different applications, and really put in place a long-term strategy to deliver transformative value and accelerate innovation and economic. So at ThingWorx, we see ourselves helping energy businesses in 3 ways, in a combination of 3 ways. The first is that we work with a number of what we call Powered by ThingWorx solution providers. These are businesses that have leveraged our IoT platform to produce solutions for the energy market. We'll hear in a moment from DvM Technology, who's produced some fantastic applications. The second is that your business can leverage our IoT platform for your own operations. So if you have internal development resources that are building applications today, by leveraging ThingWorx, they could do so. They could build applications much more faster in a much more scalable manner. Finally, if you don't have those internal resources, but really want to leverage the power of a platform, you can engage our system integrators to rapidly build applications that meet your own specific needs. With that, I'm going to turn it over to Orhan, and thank you, and I look forward to Q&A a little bit later.
Thank you very much, Scott. Do I have the screen to share? Yes. Good afternoon and good morning to some of you, to all the audience, since we have attendees from all over the world. I am Orhan Dengiz, the CTO of DvM Technology from Ankara, Turkey. DvM offers end-to-end IoT solutions to different sectors and industries, among which energy is one of the top most important. Today, I will talk about what we have done so far for the electricity market, which has some unique characteristics. I will start with a general introduction to the electricity market, following by the challenges faced by the players in the market. Then I will talk about the conventional methods to cope with these challenges versus the IoT technology's benefits. And finally, I will talk about the real-world applications that we have developed by the state-of-the-art ThingWorx platform, IoT platform. And I'll conclude my presentation with a walkthrough, real demo of the web applications. And then we will continue with the questions and answers. The national power system in Turkey has four main players: the production, the transmission, the distribution, and the end customers, in other words, consumers. The market is highly privatized. The government currently only controls the high voltage transmission network. Almost all the production is undertaken by privately operated power plants. The distribution network is divided into 21 regions countrywide. Each of those are privately operated. Also, licensed wholesalers are licensed to trade electrical energy, to buy from the producers and sell to other players in the market, or directly to the end users. Long-term contracts are also possible. The end users, if they consume more than 3,600 kilowatt hours, they are free to choose their supplier, regardless of the distribution region they reside within. So it's a highly active, dynamic market with its own unique challenges that all the players have to cope with. The way the trade goes is that the energy suppliers bid for the next day's time segments. The supply and demand relationship determines the exchange price, and the accepted bids become commitments that has to be met for the related parties. So within the day, an hourly market is open for traders. The unbalanced production and consumption needs to be balanced by the intraday trade, or it will be reflected as penalization to the players by the regulatory body. So this brings the challenges of being able to do accurate forecasting. This is both for the production facilities and also for the consumption side. The forecasts also are not only for long horizons into the future, but also short-term horizons is also important. The players have to be able to forecast what's going to happen with their production facilities within the hour, and also what's going to happen with the consumers that they serve within the hour, with the dynamic nature of this market. So apparently it's only possible with accurate real-time monitoring systems. The operators often use infrastructure and machinery from different vendors for their various power plants. It's very likely that the machines and the machinery, the IT systems, the automation systems will come from different vendors. So the data that are collected from all these distributed systems need to be brought to a single platform and run through the business intelligence algorithms to extract value out of those data. When we look at the traditional or the customary way, that's that's pretty much common in the field today. We can say that it's the conventional SCADA systems that's available at the production facilities control rooms. The data is then brought to computers within the facility or to another connected computer within the company locations, maybe the headquarters or so. Most of the time, there's going to be proprietary software systems involved with this. The results with the conventional SCADA is long implementation durations, software which is not easy to customize. If changes to the software is necessary, there's some considerable redevelopment efforts. So that's another disadvantage. Usually we see limited access to third-party tools, online systems, or other data management software when the need arises. Limited or expensive ways to bring the data to a single platform is what we see with the traditional approach. Whereas when we talk about the IoT or what the IoT technology can bring, first of all, it can be installed and it can be made ready in much less time. It's more economical when compared to the conventional SCADA systems. As soon as you take the system into service, your data becomes readily available to consume, to get consumed in many different ways at the same time. The solutions are web-based solutions, so as soon as you add something to it, or if you, as soon as you modify the software, it's up to date at the client side. It's based on real-time data, interconnected with the regulatory institutions, web services, or software, or any other business intelligence services that you want to make use of. So it's a clear advantage of implementing the IoT technology in your energy production or trade operations. So the systems that we have developed so far are addressing the consumption side, so the consumers' meters, automatic reading of those meters and bringing that data into the platform, as well as the production side. So I'm going to talk about both of them. All the applications that I will be talking about are developed with the ThingWorx platform from scratch, all the way to the turnkey solutions reaching the clients. Monitoring the consumers provide valuable real-time data from all points of interest among all the distribution regions. So let's say you're a wholesaler, or you're some sort of a supplier of electricity, and you have customers within different distribution regions. By making use of the IoT technology, you can bring all those distributed points to a single platform to do custom analytics, forecasting, that type of graphing or visualization type of operations to the data. Another benefit, like faster invoicing, if you are to invoice your consumers, it's much faster when compared to waiting for the meter to be read by the guy who visits the site, and that data officially is sent out to you, which in some cases might take up to 2 to 3 weeks. We have seen that in the real field. The market players, another benefit, have access to the real-time consumption data from the consumers, so they can do the necessary intraday trading operations optimally. The intuitive user interfaces that are always tailorable per customer's requests, and the plug-and-play IoT hardware makes possible a speedy implementation. The hardware designed for these IoT applications are completely plug-and-play, which eliminates the needs for site visits for the installations. So the daily consumptions, the hourly consumptions or monthly consumption statistics are easily conducted on the data. You can monitor, as Scott mentioned, the energy quality among the distribution regions, among the neighborhoods, etc. You can monitor the inductive, reactive, or capacitive reactive usage, and you can generate alarms so that the consumers can take necessary precautions against possible penalizations. And any type of custom analytics and graphing can be applied to this data on the web applications as well. So who could benefit from such a system that enables the consumption monitoring in real time? It starts actually from a single household. We have seen that even a single household, when they have access to their real-time consumption data, they can benefit from this by rearranging their habits, etc. Or if you have a couple of thousands of points that you would like to collect real-time consumption data from, the IoT is for you. It's a scalable system, and whether your facilities are distributed worldwide or within one nation, it does not matter at all. You might be interested in monitoring your end customers, as well as your distribution regions. One very important thing that IoT could help you do is to transform your business. Most of the time, we also see that in the real applications on the field. The companies who implement the IoT solutions also use that to provide additional services for their customers by making use of the power of IoT. So it helps them generate new business opportunities, maybe additional revenue sources, or they can simply use the IoT systems as a sales tool to increase their sales to potential customers, because the customers always choose the suppliers who also could provide them with some real-time usage statistics. At the production site, the case study that I'm going to talk about involves one of the largest producers in Turkey, 18 power plants nationwide, with 27 points where they supply energy to the national grid are monitored constantly. 8 of those are wind power plants, 4 are natural gas combined cycle power plants, 4 of them are hydroelectric power plants, and 2 fossil fuel power plants are among those 18 power plants. And most of them come from different manufacturers. The generators are different. the gas turbines are from different manufacturers, etc. Again, by making use of the power of IoT, we have a gateway design that fits all metering systems from different vendors. It makes unattended installations possible. Also, the data from all these monitored points are brought to a single platform for visualization and for real-time analytics. It easily integrates with any other third-party tool or system over the internet, and that includes the regulatory bodies' systems and services, plus weather services, which is very important for the renewable energy sources like wind power or hydroelectric, solar generators. There, the weather conditions, wind or rainfall, or the solar radiation has a huge effect on the production when it comes to forecasting or when it comes to monitoring the efficiency of the systems that are currently running. So this concludes my presentation from the slides. I would like to jump to the web applications that we have developed by ThingWorx. This is the production power plant monitoring system. The initial page that the users land to after they log into the system. It's a summary map where they can jump from one facility to another to get the current power that's being generated at the facility. The total production tab takes them to, again, a summary dashboard which summarizes what has happened in the last completed hour. In this upper, let me switch to the spotlight. The upper left section, the bar charts that we see, this one on the right-hand side is what had the company, okay, what has the company, oops. Anyway, so let me just, so the last completed hours numbers are 997 in this demo. This green rectangle in the middle states what the expected generation will be within the end of this very hour, which about 37 minutes have been completed so far. And then the okay, now I need to correct myself. The last hour is this first rectangle here, and the third rectangle, the blue one, is what the expected end of the current hour will be. So this is the short-term forecasting here. So we expect this hour to complete with 1,039 megawatt hours of energy, whereas the completed hour ended with 997.3. The current total power, that's the sum of all the facilities throughout the country, is 1,125 megawatts. The current daily total production for the first 16 hours and 38 minutes is stated in this red rectangle. Right next to it is the total monthly production, which is up to date to the last minute. Every minute these numbers will be updated. This hour until now, which is the 38 minutes production within the hour. Again, monitored every second and updated every minute. Our total predicted is, again, stated in numbers, which is also represented in this rectangle there. The chart, which is on the left bottom corner, shows us the daily production beginning at the beginning of the month for this current month. That's so this is for March 2016. This summary chart over here is the hourly energy generated for this day, starting from the first hour all the way to the end of the 16th hour. And right now we are at the 17th hour, which will be completed within the next 20 minutes. And whatever data is recorded over here will be positioned as the rightmost column. So different dashboard designs might be preferred by different departments within the organization. And it's really easy with the with this platform, with this tool, to generate different custom dashboards to address different requirements from the client. If they would like to see facilities by themselves, this is the summary dashboard for that. And similarly, day by day, what had been accomplished at that specific facility, what's the current total power, and what's the utilization rate. It's all under these items, or in the list to the left. If they would like to go into more detail to, to the power meter that's being monitored, they can run historical runs on the data, so they can bring from whichever time interval that they're interested in. They can also export the data to Excel if they'd like to run some custom analysis on them individually. Again, for the single points of connection to the grid, they can analyze, monitor the current total power, capacity usage, what had happened within the hour until now, and within the day as a daily total. These screens are all developed per customers' or clients' requests. I'd like to talk about this administrator screen. This is designed to give them administrator rights to change the settings, the facility names, the additional tags that they would like to attach to the meter, and set a position to their facility. So it can be a completely client-managed system. So whatever device they would like to manage, whether they want to take it out from this facility, put it into another one, or move from one location to another, they can change the settings accordingly so that total control over their devices is granted for the customer. This weather tab is a demo for the connected weather forecasting systems, monitoring and forecasting for specific facilities. The current weather conditions, historical data, which shows the past weather conditions versus the generated energy, so that they can analyze the data for correlations or other needs that they might be interested in. Export the data to Excel for this table or for the comparison chart here. Again, with a single click, they get the ability to export the data. One final tab that we have here, which we call the external map, is designed as an executive screen, which is actually highly preferred with our clients. At a glance, they get all the facilities on a single map with necessary real-time information. If they want to zoom in, if they want to zoom into an area or region of interest, they can do so. Clicking on one power plant, they can reach the most recent, whichever time duration they prefer, they get to that most recent data. The type of the power plant is expressed by these icons, depending on the fuel type, the renewable source, or let's say these wind power plants over here. It's all accessible through a single click on their fingertips. This summary over here is a real-time compilation of the total power generated by these power plants, depending on the let's say the fuel type or the renewable energy source type. The natural gas plants are accounting for almost all the maybe 90% of the current generation. 24.62 megawatts coming from the hydroelectric, 59.12 coming from the wind power, 202 megawatts coming from the fossil powered power plants. So it's really really fast and easy to implement such a system, and to complete the overall development of this IoT application by using the state-of-the-art ThingWorx platform is much faster than any conventional method that could be followed. This concludes my presentation at this point. I would like to turn the microphone back to Patricia to start our question and answer session. Thank you very much.